Good afternoon, Professor. Today we're excited to present our project for database management systems. We are Group 3, consisting of Zhenming, Ai Ying, Zhen Wei, Manesh, Ying Ee, and myself, Jasbir. We are here to present WAZY, an application that uses sandbox trading to allow users to practice trading in a risk-free environment with the aim of bridging the gap between financial literacy and a hands-on investing experience. Before I go into further detail, here's an overview of what we'll be covering in our presentation. Let's begin with covering the backstory of our app, WAZY. Financial literacy is a growing concern among young adults in Singapore. Research has shown that 55% of adults consider themselves to be financially illiterate. Yet, many young adults actively invest as they recognize the importance of investing early in life. However, their enthusiasm often outweighs their financial knowledge, leading to poor financial decisions and, in some cases, severe losses. This gap between enthusiasm and knowledge highlights the need for a safe environment where young investors can learn to interpret stock data, develop trading strategies, and manage their portfolios without the risk of real-world financial losses. That's where WAZY comes in, offering a paper trading environment that provides a practical, risk-free learning experience where users to experience stock trading and virtual portfolio management.
These are the applications and datasets used for our application WAZY. We use Vercel as a cloud platform service to allow fast serverless deployment, scaling of web applications, and continuous integration through GitHub for our application to be used in the World Wide Web. We use PostgreSQL for our database and tables. To manage the database and tables using PostgreSQL, we use pgadmin as a GUI tool. We also use Node.js to run our Java scripts on server side, such as chart.js or any internal scripts that we use to retrieve the query from the database.
Our relational database efficiently manages user data, stock transactions, market information, and ESG scores. Each user has a single portfolio linked through the portfolios table. Stock and money transactions log all activities, while stock prices, news, ESG, and sentiment tables store relevant stock data, including real-time prices, news, ESG scores, and sentiment analysis, offering a comprehensive data structure for trading decisions. Now, on to the datasets we've used. We've incorporated the Yahoo Finance, Amber Finance, and FinBrain Technologies API for real-time stock data and sentiment analysis. Additionally, the Gaia Lens ESG Scores API helps users to make socially responsible investments. These datasets collectively provide accurate and insightful data for a realistic paper trading experience. With this robust schema and reliable datasets, we enable an informed and engaging trading experience.
Hi, my name is Zhenming/admin, and today I'll be demonstrating our application. So first of all, you open the browser and search wazy.vercel.app, and you'll be greeted with our login page. So now let's sign up for an account. Let's use the name WAZY, wazy@gmail.com. Password is WAZY, confirm password is WAZY as well, and we register. And you will be greeted with our home page. So let's look at the profile page first. First of all, you'll be, by default, you have $1,000 and no portfolio. Let's deposit $1 million for now. And once you click on deposit, you can see that your balance is updated and is reflected on the history page as well. Now you go to the home page, you can see there's many stocks. All these stocks are actually real-time data. The price, high price, low price, the ESG score, the news is also real news as well. So all this information are actually pulled from the Yahoo Finance API. So it's actually, we store the information in the database and we're presenting it here. So now let's say we're going to buy some stocks. Let's buy 100 Apple shares. And then we're gonna buy 200 Amazon shares, right? As you can see, right, after purchasing this, you can go to profile, you can see that it's actually showing a pie chart. And after that, you can also withdraw some amount here, let's say 5,000. And let's say right now I want to sell some Apple stocks. I have 100, I'm gonna sell 50 of it. Once I finish selling, right, go to history, you can see that it's actually reflected here as well. So let's say I finish all my actions, I'll be like, I don't need this account anymore. I just click on delete profile, and this will be completely deleted off the database. For example, let's say I try logging in again, wazy.gmail.com, and use WAZY as a password, login. You can see that this account doesn't exist anymore. So that's a simple CIOD demonstration of our database project. Thank you.
Thank you, Emin. Now let's move on to the product functionalities. Our platform provides a portfolio dashboard that visualizes key information for users, including high prices, news sentiment ratings, and ESG scores, which are extracted from the API. Additionally, we also display users' transaction history and wallet balances. Next, we have 4 key product highlights. For handling complex queries, we utilize join, union, on conflict resolutions, order by clauses, and distinct functions in our code. In terms of security, we implemented password hashing and encryption along with role-based access controls. We also have enhanced the query efficiency by employing direct queries and caching data. Finally, we integrated API usage to extract the relevant data sets. Now I'll pass the time on to Manesh.
Thank you, Ai Ying. I'm Manesh, and now I'll be going through the constraints we have implemented in our application. Firstly, we utilize primary and foreign keys to prevent creating redundant data sets in multiple tables. Next, we have used the check constraint to limit the value range that can be placed in a column if required. And lastly, we take advantage of the unique constraint to provide a guarantee for uniqueness in relevant columns. Next, I'll be covering the performance analysis and optimization we have implemented for our app. For our API calls, we have optimized the overall response wait time and data processing by having concurrent calls over sequential calls. In cases where you have to handle both insert and update queries, we make use of on-conflict resolution to minimize potential race conditions and optimize the overall query logic. Lastly, we practice parallel query execution whenever simultaneous data retrieval is required to achieve a significant reduction in latency and a faster response time for users. Thank you for your time. We are Group 3 and this has been our sandbox trading app WAZY.